Hello and welcome to AGN 3613. By now we understand the time value of money and how to calculate the equivalence of a dollar at any time in the future. In addition, we learned to calculate present value or present worth. We learned annuities, we learned interest rates, and we learned how to calculate number of periods. After learning the main concepts, we need to learn how can we use these calculations to manage our money and to take better financial decisions. To understand money management, we need to understand the numbers on our credit card bill. What will happen if you pay the minimum only? If you paid 2% of your balance of $2,705 on a card that has interest rate of 18.38% over 27 years and 2 months, you will pay $11,047. And that's based on calculations that were published in the US Today back in 1998. So imagine how would it be like now. The $2,705 was paid back more than 4 times, assuming that you will not add any balance to this card, you will not buy anything on that card. So we need to understand the language to be able to manage the money. Should we pay the minimum? Should we keep on paying for the next 27 years? What does nominal interest rate mean? What's the difference between nominal and effective interest rates? All these questions need to be answered to be able to understand the language. Let's start with the difference between nominal and effective interest rates. Nominal interest rate is the rate of interest before adjustment for inflation. The nominal interest is known as an annualized or annual percentage rate or APR. And this is what you see on your credit card offers or statements, the word APR. APR is the periodic interest rate divided by the number of periods per year. For example, a nominal annual interest rate of 18% based on a monthly compounding rate means a 1.5% interest rate per month, while effective interest is converting the nominal rates into annual compound rates or interest. So again, what does 18% compounded monthly mean? The 18% is the nominal interest rate, or what we call the annual percentage rate. Monthly means the interest period, which could be also daily, weekly, quarterly, any other period of time. So I have 12 periods per year, which means that n is equal to 12, and the interest rate per period is 1.5%. Multiplying the number of periods with the interest per period, we get 1.5 times 12, that will equal to 18%. Now let's go back to our famous equation to find the future value. Let's look at the future value of $1 invested in a bank account for 12 months. Now remember that the principal here is $1. The interest rate is 1.5% per period per month, and I have 12 periods. So n is equal to 12. And the formula is future amount is equal to 1, which is the principal, multiplied by 1 plus I to the power n, which is in this case 12. And of course I is 1.5%, so it will be 0.015. Calculating the value, it will give us $1 and around 19 cents, and that is after 12 months or after a year. Now looking at the interest, you can see that the interest rate over the year, over 12 months period, is equal to 19.56%. So it's not 18. And that is what we call the effective interest rate. So the effective interest rate in this case is 19.56%, which is compounded annually. In other words, 18% compounded monthly or 1.5% per month for 12 months is equal to 19.56% compounded annually. We can also translate that into a different language, which is the investment and borrowing. So if you borrowed money from a bank, the bank will charge you 1.5 interest each month on your unpaid balance. Now, if you deposited that into an account, investment account, then you will earn 1.5% interest each month on your remaining balance. To calculate the effective annual interest rate, we use the formula IA, and this is annual for annual. So IA is equal to 1 plus R, and R is the nominal interest rate per year, divided by M, and M is the number of interest periods per year, all to the power M, and all minus 1. So this will be the formula that we will use to calculate the effective annual interest rate. The effective annual interest rate. Let's look at the following example. If your credit card calculates the interest based on 12.5% APR, what's the monthly interest rate and the annual effective interest rate respectively? Remember that first we need to calculate the monthly rate, which can be done by dividing the APR, the 12.5%, by 12 months. So the monthly interest rate will equal to 1.0417%. Divide 12.5% by 12, and you will get 1.0417%. Now let's see the solution for this problem. So the effective annual rate will equal to the IA will equal to 1 plus 0.010417, and that's the interest, all to the power 12, and that's the number of periods, n, all minus 1. Calculating that, you will get 13.24%. So the annual effective rate is equal to 13.24%. It's not equal to 12.5%, and that's the difference between the nominal and the effective interest rate. Now, what would happen if you missed 2 payments? Then you will be charged for that interest of 1.0417 per month, and the future amount after 2 months, you can use the formula as we did before and calculate that, and you will get $2,041.88, and that will be your calculation. Another practice problem. Suppose your saving account pays 9% interest compound quarterly. If you deposit $10,000 for 1 year, $10,000 for 1 year, how much would you have at the end of that year? Since I'm dealing with an interest rate that is compounded quarterly and not monthly, then to find interest per period, we need to divide that value by 4 instead of 12, because I have 4 quarters or 4 paying periods. So the interest rate per quarter will equal to 9 divided by 4, which is equal to 2.25%. The annual effective rate will equal to 1 plus 0.0225, and all that to the power 4. That amount, whatever result from that, will be subtracted, or you subtract 1 from it, and you will get 0.931 or 0.0931, and that is equal to 9.31%. 9.31%. Back to our formula. To calculate the balance at the end of 1 year after 4 quarters, that will equal to 10,000 multiplied by the factor, which is F given P with 2.25% and 4 periods, and that will equal to $10,931. This table shows the calculation for each year, and you can see how the value is increasing, and we are actually charging interest, the 2.25%, on the new value, the new amount. This table shows the different effective rates based on the different compounding periods, with semi-annual, which we divide by 2, quarterly we divide by 4, monthly we divide by 12, a weekly we divide by 52, daily we divide by 365, and of course after that we have the annual. So starting from the annual to the daily. Why do we need an effective interest rate per payment period? Since the interest is based on time, it's important that the interest be relative to the payment period. In other words, it's important to have an effective interest rate per payment period. For example, the interest has been given compounded monthly while the payment is quarterly. We need first to calculate the effective interest rate, then calculate the quarterly payment. That will be all for this session. If you have any questions, you can email it through any of the given communication channels. Thank you and have a great day.